Okay, welcome to lesson 24. We will continue with lists. So in the last lesson we were talking about slicing. Let's continue with slicing and some methods about lists. So as you know, this is the syntax of slicing, the name of the list, A, starting index, B, the ending index, and S, step size. Starting index, which is inclusive, or you should include A. Here we have the ending index, which is exclusive, and S, step size. So let's have a list named X with 5 elements, 1, 2, 3, 4, and 5. Let me write down the indexes, both positive and negative indexes. 0, 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4, and minus 5. So print X 0, minus 1. So 0, starting index. So we have to print all elements from 0 until minus 1, which is the last element. So minus 1 here means the last element. So again, it means print everything except the last element, which is 5 here. So this is the output, 1, 2, 3, 4. Now we can have the same output using another form of slicing, X. So no need to write starting index, you just write colon, and here minus 1. So whenever you don't write anything as starting index, it means print everything from index 0. So print everything or get everything from the beginning until minus 1, the last element. 1, 2, 3, and 4. So these two are equivalent. So let's have another example. Print X minus 2, colon, and nothing else. So let's say you have minus 2. So this is not the line of real numbers, it's just a line. So see this line as a line, just a line. So here you're moving backward, here you're moving forward. So minus 2, so this index here, to the end. So print everything from minus 2, the element at index, minus 2, up to the end. So what we have at minus 2, we've got 4. So we print 4. So here we don't have any value, it means print everything. Or move forward. So move forward means step size is positive. So whenever you have a negative number as step size, it means you're going to the left. You're going backward. You're moving backward. So here we have minus 2 and nothing here. All the elements, step size is 1, so we are moving to the right. So we print 4 and 5. So let's have another example. Print X minus 2, colon, minus 1. So what do you think? Minus 2, minus 1. Step size is 1. So this is just one step, plus 1. So whenever you have any step, it means you can print something. And this one here is minus 1. Do we have any step? Yes. Because step size is 1. So you can see it makes sense. Minus 2 plus 1 minus 1. Yes, we have one step. So it means you can print something. What is that something? Here is 4. So we have print x minus 1 colon. So from minus 1 up to the last element. So here, minus 1 is the last element. From the last element to where? Nobody knows. And we don't have any element here. So basically, we print one element, which is 5. Or let's say from the last element to the last element. Print x minus 1 colon minus 2. So what do you think? Do we have any step here? Step size is 1. The default value is 1. So minus 1 plus 1, it means go to the right or move forward. It becomes 0. But here it says minus 1 to minus 2. So we don't have any elements. We can't print any elements because we don't have any proper step. So we don't print any element here. But what if I go backward? What if I go to the left? Can I print anything? Minus 1 colon minus 2. Now this minus 1 is not the default value of step size. Now this is our step size, minus 1. So it means go to the left or move backward. So we have minus 1 here. Minus 1, we get minus 2. Do we have a proper step? Yes, we do. We are going backward. So what should I print? So remember, this one is exclusive. So minus 1 from this element. We start from 5, so we just print 5, nothing else. Because this number here, minus 2, is exclusive. So you can't write 5 and 4, just 5. This is important because of two libraries, mostly two libraries that we work with, NumPy and Pandas. Slicing is really important when it comes to these two libraries. You have to know how to retrieve some elements, multiple elements at the same time. So this is why you have to know slicing. You have to learn slicing properly. Now let's talk about another method. It's called index. So let's have a list. X equals 10, 20, 30, 50, 100. So here we have 5 elements. So what does it do? It gives you the index or the position or the location of the element that you want to get, its location. So if you say x dot index, so here you don't write the index, you write the element that you want to get its location. So let's say 30. So let me write the element, not the index. So 0, 1, 2, 3, 4. So what is the index of 30? Yes, it's 2. So this is the output of this one, 2. Now let's have x dot index 52. Do we have number 52 here? No. If one element doesn't exist in the list, you will get an error. So let's write, it causes an error. So as a note, if the element doesn't exist, you will get an error. So first you have to check if that element exists in the list. Can we use index with strings? Yes, you can use index with strings. Let's have s equals, let's say window, and here s dot index, let's say n. So as you know, string is just a sequence of letters or characters. So you can write it in this form, just to simplify things for yourself. N, D, O, and the last one, another W. So here, the index is 2. So I'm sure you've noticed that we have 2 W's here. So what if I say s.index W? So what do you think? 0, 1, 2, 3, 4, 5. Will I get 0 or will I get 5? Or maybe both of them? And the answer is you'll get 1 index, which is 0. So if you have any duplicate in your list, the index method gives you the index of the first occurrence of that element. So as a note for you, if we have duplicates, the index method, let's say, returns the index of the first occurrence. Not all of them, just the first occurrence. So let's finish the lesson here. So next time we will continue with in and not in operators. So to check if we have an element in a list or if we don't have an element in a list. So as usual, take care and bye-bye.